Hello everyone. Today we're going to talk about an Akka.NET feature we just shipped that gives you free observability into the way your Akka.Streams graph works. Now, these are some issues from the Phobos issue tracker. So this is from 2021, asking about support for Akka.Streams Kafka. This is an epic that I put together in 2022. We had lots of people that were using Phobos who wanted to be able to visualize all of the individual graph stages that compose an Akka.Streams graph. Now, we've done a number of videos on the channel about Phobos, which is our commercial product we sell. It's basically OpenTelemetry integration for Akka.NET. And the key things that Phobos does is it basically propagates context automatically, comes with built-in dashboards, and is able to work across Akka.Remote, instrument Akka.Persistence, and it's able to kind of taper down all of these sources of noise that you might end up observing inside a really busy Akka.NET application. Phobos has a lot of knobs and dials to help you manually configure that, as well as a lot of good built-in defaults to help make sure you don't produce information that's too noisy and too expensive to retain. But the way Phobos works is primarily instrumenting actor-to-actor communication. If I go dip into here, the way it largely works under the covers is actors that get instrumented with Phobos basically begin carrying tracing context back and forth through normal actor messaging. And that is all fine and good. The problem is that Akka.Streams graphs don't quite work that way. If we take a look at, for instance, this Akka.Streams graph, which is built into the Akka.Persistence.Sql plugin, this is what we use for batching writes together. So what we're going to do here is we're going to create a Source.Queue. We're going to do BatchWeighted, where we're going to basically specify a transaction size, and we're going to aggregate rows together into a set. And then once one of these sets is emitted, for every degree of parallelism we support here, we're going to go ahead and basically create a promise per row. We're going to go and write these journals to SQL, and then we're going to communicate the errors back basically down below here. The gist of this is that what Akka.Streams is going to do is materialize this graph into a bunch of different actors that communicate using these very circular looking push and pull sort of metrics. And looking at the actual actor communication here, back in the early days of Phobos, before we stopped trying to trace Akka.Streams, you would get these graphs that would be like hundreds of thousands of spans long, which is way too big to be actionable by a DevOps team. Even an LLM would have trouble with that these days. Instead, what people want to see is what the Akka.Streams graph actually looks like. And this is what that graph we just saw in code looks like represented as an Akka.Streams flow. You have multiple actors, all persisting events. The Akka.Persistence journal is going to queue these up inside the write queue. We're going to basically batch all of these different operations together. And then for each one of these parallel batches, we're going to go ahead and insert them in batch to SQL Server. And if the batch succeeds, we're going to take all of these promises, these little tasks that get created right here, and mark them as complete so the persistent actor knows they were able to successfully finish their write. That is what users really want to see, is they want to be able to see this flow execute end to end in this exact shape. So one of the things that we've done is in Akka.NET, I think it's 1.566, yes it is, we introduced this flow right here, end-to-end OpenTelemetry trace context propagation. Because of how Phobos works, where it gets injected into your actor system and wires up all the actors, basically Phobos can instrument actor-to-actor communication pretty well, but Akka.Streams, as we've just seen, has a very different looking shape. And so in order to capture this properly, we had to bake it directly into Akka.NET itself. Namely, we stick it in an Akka.Streams component called the GraphInterpreter, which is basically what wires up all the Akka.Streams stages together and allows them to kind of communicate back and forth, pushing and pulling when there's upstream messages and downstream demand. That's how Akka.Streams achieves back pressure, which you've probably learned about in one of our videos. So what we do is we ship this in Akka.NET 1.566, and the newest versions of Phobos all automatically instrument it. And I want to show you what that looks like real quickly. This is TextForge, one of the new software as a service applications that we launched here at Petabridge. Basically allows you to kind of delegate your inbox to a large language model. And we use Akka.Persistence.Sql backed by Postgres in production here. And so one of the things I wanted to kind of show you real quick is what the new tracing output actually looks like from this tooling. So we're going to flip over to Seek here. So this is what rejecting a draft in TextForge looks like. So we're using Blazor Server here. So I go and I click this button. And that results in the basically the SignalR connection built into Blazor Server firing an event back. I have a little manual event from TextForge itself here. And then this is all Phobos stuff that we're capturing here. All this, all the way up until we hit this Akka.Stream.Ingress queue source. This is basically a message stepping into a stream from the outside. And then we have our batch, then we have SelectAsync, and then we have another ingress step right here. This basically means we're shifting from essentially having the message queued into SelectAsync to actually having it exit again via some actor messaging is what's happening here. And then well, actually not actor messaging, there's really SQL transactions that are happening under the covers there. And then finally we hit the very end, the ignore sync. And then all the other stuff kind of confirming that the write's been done and happens here. We can even see a webhook get dispatched as a result of this, some distributed pub sub. We get this message back and we go ahead and we do some cleanup on the persistent entity. And all this workflow looks like it took about a second in this particular instance, but this is the whole workflow, including the webhook dispatch, all happening under the covers here. So in order to get access to this, all you need to do is install Akka.NET 1.566 or newer. And then you want to go ahead and make sure you register the Akka.Streams source on your OpenTelemetry sort of registration. So if you go and you add the Akka.Streams named source here with this exact key, you'll begin being able to get these traces and they'll be visualized in the actual shape of your graph, just like we have here. So let me know if you end up trying it, if you have any thoughts or opinions on how we can make it better. If there's any graph combinations or Akka.Streams plugins that don't work yet, please let us know. We expect there's probably going to be more work we have to do in order to make sure that this works consistently across a larger number of Akka.Stream design types. But for everything we've tested against, it's working very, very well so far. Please let us know what you think and if there's anything we can do to make it better. Thank you very much.
Well, that'll do it for this video. If you found this video useful, please don't forget to check the description to find links to other resources we may have included, so blog posts, GitHub code samples, other videos, so on. And as always, don't forget to like and subscribe and ring the bell for notifications. We'll catch you next time. Thank you very much.